I think what I'd like to do is start with the function y equals x cubed, and just quickly go through that. So the x-intercept would be when y is 0, so you get 0, and the y-intercept would be when x is 0, so you get 0. And if we wanted to find the stationary point, okay, then remember it is derivative equals 0. Okay, so remember we said that if we have a curve, there are infinitely many gradients to the curve, right? And the one where the graph turns is a flat line, so it has a gradient of 0. And another word for gradient is the derivative. So it's where the derivative is equal to 0. So in order to find a turning point or a stationary point, we need to find the derivative and equate it to 0. Right, so the derivative of x to the 3 is 3x squared. And then if we divide by 3, we get x squared equals 0. And if we square root both sides, we get x equals 0. And so, of course, we end up with the same point. If we sub the 0 back in, y is 0. So after exhausting, doing the x-intercept, y-intercept, and stationary point, all of the points are 0, 0. And so what I can do is then just do a bit of a table. So plot points on either side, and you will see that the graph does something like that. Okay? It carries on indefinitely, of course. Right? And what I'd like to discuss is the concept of concavity. Right, concavity happens where there is a point of inflection. Okay, a point of inflection. Okay, and we'll find the formula just now for the point of inflection, but concavity happens where there is a point of inflection, all right? And we get concave up and we get concave down. Now, in order to find where a graph is concave up, it is where the second derivative is greater than 0. And it is concave down where the second derivative is less than 0. Right, so what is the second derivative? Well, the first derivative is 3x squared. So the second derivative is the derivative of that. So it will be 6x. So if we work out, it's 6x. So my second derivative is 6x, so 6x is greater than 0. And if I divide by 6, I get x is greater than 0. Now, if you look at the graph, x greater than 0 is on the right-hand side, on the positive x-axis. So it's this graph. And you'll notice that if you draw a tangent to the graph anywhere on the positive x-axis side, do you notice that the graph is above the tangent? Anywhere where I put a tangent, at any point, if I draw the tangent, the graph is above the tangent. All right, so concave up is where the graph is above its tangents. It's quite an important concept. All right, so the graph is above the tangents where it is concave up. Right, so I purposely did this example because I wanted to demonstrate what it looks like. That is concave up, where the graph is above its tangents. Whereas concave down is where the second derivative is less than 0. So 6x is less than 0, so x is less than 0. X is less than 0 on the left-hand side, so where x is negative, it's this graph. And if we were to draw the tangent to the curve, any number of tangents to the curve, do you see that the curve is underneath the tangents? So a graph is concave down where the graph is under its tangents. Right, so this is very important. It's a good idea to have a good knowledge of what concave up means, what concave down means, not just algebraically, but also in reality what is happening, pictorially, looking at the graph, graphically, what does it look like? All right, so any graph that does something like this, if you draw the tangent to the graph, if the graph is above the tangent, it is concave up. Whereas if a curve curves like that, if you draw a tangent, the graph is under the tangent. That is concave down. All right, so there we go. That is a nice run over of concave up and concave down. Now, I mentioned that concavity, the change in concavity happens where there's a point of inflection. Now, the theory for the point of inflection is where the second derivative equals 0. Okay, so the second derivative we said was 6x equals 0. So second derivative equals 0. So when x equals 0, if I divide by 6. And if I substitute the 0 back into the original, I get the point 0, 0. This is called a point of inflection, okay, where the second derivative is 0. And you can see why it is a point of inflection. It is where the concavity changes. So where it went from concave down to concave up. All right. Whenever a graph goes from concave up to concave down, or concave down to concave up, it does not turn, it inflects. It inflects at the point of inflection. And on either side of the point of inflection, there is a change in concavity. Okay, the one side will be concave up, the other will be concave down, or vice versa. Right, then another thing I'd like to look at, and I'm going to use the same graph. Right, so this is what the graph looked like. If we look at this graph, y equals x cubed again. As we move along a graph, please understand that when we read a graph, we read it from left to right. So if we move along the graph, we move from left to right. That means that as we move along, the x value is always increasing. Right? As we move along the graph, x is automatically increasing. What is happening to y? Well, the y value there is that, then there it's that, then it's that. Do you see that the y value is increasing? Every time we go to the graph, the y value is getting bigger. Right. So this graph is increasing everywhere. Right? So the graph would increase where y is an element of real. Any y value, it is increasing. There's nowhere where the graph is decreasing. It's always getting bigger and bigger and bigger and bigger. The y value is getting bigger. So when we say a graph is increasing or decreasing, we mean the y value of the graph when x is automatically increasing, because we read from left to right. So that means x automatically increases. Okay. Right, so we can actually see from this graph that the graph is increasing. Now, if I draw all the tangents to the graph, do you agree that all the tangents have a positive gradient? Okay, so positive or increasing, positive gradient. What does that mean? It means m is greater than 0. Gradient is positive. M is greater than 0. And what did we say another word is for gradient? Derivative. Okay, the derivative is greater than 0. So a graph is increasing where the derivative is greater than 0. That is theory, you need to learn it. And in exactly the same way, a graph is decreasing when the derivative is less than 0. And we learn it. We either learn it or we have it visually in our head where we can picture it and always imagine the tangents to the curve. That way you know, okay, the tangent along the curve, everywhere I draw it, it's always got a positive gradient, positive m. M is greater than 0, but m is the derivative. All right. Remember, the derivative is the general form of the gradient, okay? But it would depend what the x value is, what the gradient would be. I mean, that gradient is completely different to this gradient, right? They don't need to be the same. Right, so some theory. Increasing, learn that the derivative is greater than 0. Decreasing, learn that the derivative is less than 0. Why is this important? Because we could ask you for which values of x is the function x cubed, y equals x cubed. For which values is that function decreasing? And then as soon as you see the word decreasing, you go, oh, derivative 3x squared must be less than 0. Right? Which means I need to solve this. Right, now there are two ways to solve it. First of all, you can do it by inspection. Anything squared is positive. Times a plus 3 is positive. So this is always positive. So can it be negative? No. So therefore, there's no solution. Therefore, it does not decrease. And you can see from the graph that it does not decrease. It increases, right? Right? If I had said for what values of x does the function increase, right? Then you know that it's where the derivative is greater than 0. Anything squared is positive. Times a plus 3 is positive. Right? So this is positive, which is greater than 0. So therefore, x is an element of real. X can be anything. No matter what x is, it is always going to be increasing. Right. Now, I just want to point out a little bit of a technicality here. There isn't an equal. So technically, x can't be 0. Now, different books and different syllabi will handle this differently. And even within a syllabus, it would differ sometimes from one memo to the next. At 0, it is a point of inflection. And at the point of inflection, it is neither increasing nor decreasing, actually. All right. But having said that, they probably would accept your answer as is. I'm just pointing out that there should technically be an equal there for x to be included, so that x is an element of real, meaning x is anything, including 0. But technically, x is not included. I just want to mention that. All right, so we've looked at increasing and decreasing. We've looked at concavity. Right, two very important concepts, and that is besides the stationary points. All right, so what I'm going to do next is a different example, which tries to demonstrate a lot of concepts, okay? So, I'm going to look at the function x cubed minus x. I'm going to look at that function, and for this function, we are going to find all the points needed so that we can sketch the curve, right, in order to sketch the curve. So remember, when we're sketching curves, we really want the 3 main points firstly. The y-intercept, the x-intercepts, and the stationary points, okay? The x-intercepts we find by letting the y-intercepts we find by letting x equal 0. Remember, f of x means y equals, and 0 cubed minus 0 is 0. So the y-intercept is 0. The x-intercept is when y is 0. Right, so I'm going to make y 0. So it's where this equals 0. And I then treat this like a normal equation. Everything to one side equal to 0, factorize. Take out the x, you're left with x squared minus 1. So either x equals 0 or x squared equals 1, so x equals plus or minus 1. Or you could have squares, okay? Those are my x-intercepts. So there's one at minus 1 and one at plus 1 and 0 again. All right, so far I have those 3 points that the graph goes through. I now need to find my stationary points. Stationary points is where the derivative equals 0. Okay, so where the derivative is 0. And the derivative is 3x squared minus 1. And that's quite easy to solve. X squared equals a third. So x will equal plus or minus 1 over root 3. It's the square root of 1 over 3, but the root of 1 is 1, and I can't root the 3. So that means I have 2 stationary points. One has an x of 1 over root 3. The other has an x of minus 1 over root 3. And then I'm going to substitute those back into the original. Right, so if you have your calculator handy, I'd like you to please work out 1 over root 3 cubed minus 1 over 3. Okay, so 1 over root 3 to the power of 3 minus 1 over 3. Oh, sorry, 1 over root 3. Just be careful that when you move your arrow down on your calculator, that you make sure it's next to the fraction, next to the brackets, not in the power. Okay. So it's that and then minus 1 over root 3. All right, the perfect answer is the following. Minus 2 root 3 over 9. But in real terms, if you push SD, you'll get minus 0.38, so minus 0.4, more or less. That just helps you plot it a little bit easier. You can't really relate to minus 2 root 3 over 9, okay? So just always put your perfect answer as part of your stationary point, but then for your own self to go and plot it, just work out what it is. And the same goes for the 1 over root 3. In fact, before I do that, I'm just going to go back and change this to a negative 1 over root 3. So that would become a plus, and that would become a minus. And then just tell me if you agree with me or you don't agree with me. And then, of course, if you work that out, that is 0.38, so 0.4. And I just want to work out what 1 over root 3 is. Okay, it's 0.6. So 0.6 and minus 0.6. So that just makes it easier to plot, all right? So in other words, I have a point, a turning point, stationary point at 0.6 and minus 0.4. So somewhere there. And then I have another one at minus 0.6 and plus 0.4. So like there. And you can already see what the graph looks like. The only way you can join those is to do this, right? But I'm not going to do that yet because I want to show you something. We now come to a very important part of sketching a curve, and that is to test for max or min. Okay, so to test for max or min is now your fourth step. Okay, y-intercept, x-intercept, stationary points, and then test for max or min. You test it by finding the second derivative. Right, so what would the second derivative be? Second derivative is the derivative of the first derivative, which was 3x squared minus 1. So it will be 6x. And what you do is you substitute the two x values into the x. So these two. So you work out 6 times 1 over root 3, which is greater than 0. And if the second derivative is greater than 0, it means that there is a minimum at this point. And when you substitute in the minus 1 over root 3, you'll get a negative answer, which means that there is a maximum at this point. And what does a minimum look like? It looks like that. And a maximum looks like that. So at this point, the first one, this one, it looks like that. So you just do that there. You put a little curve. And at the other point, which is that one, there's a little maximum. So you just do a little curve. And then you can see it's very easy to sketch the curve. All right, there we go. That is basically how you sketch a cubic function. There's quite a lot of work involved. In your final exam, you could get a question that literally just gives you a function and says sketch it. In which case, you have to do everything that I have done on this page. All right? You have to find the y-intercepts, the x-intercepts, the stationary points, test the stationary points for max and min. And on top of that, you have to find the points of inflection. In other words, where the second derivative equals 0. The second derivative was 6x. So where 6x equals 0, so x equals 0. And if you substitute that back into the original, you'll get 0 cubed minus 0, which is 0. So there is a point of inflection at 0, 0. Okay, you can't see anything happening there, but you know that there's a point, if there's a point of inflection, there's a change in concavity on either side of that point of inflection. So if I went to find where the graph is concave up and concave down, there's definitely going to be a change in concavity here, okay? That's probably going to be concave down, and this is going to be concave up. Why? Because here, if I draw a tangent, the graph is above the tangent, and there, the graph is below the tangent. So concave down and concave up. Then just as a matter of interest, where is the graph increasing? Reading from left to right, moving along the graph, do you agree the graph is increasing, the y is getting bigger? Until it hits the turning point, then it decreases, till it hits the turning point, and then it increases. So this graph would increase from negative infinity up to that value, which is negative 1 over root 3, and it would increase again from positive 1 over root 3 to infinity. You can see that from the graph. Right, so that's a nice overview of what sketching a cubic function entails. And in fact, generally going forward, if you carry on with maths at university, generally this is the method. You do your steps, y-intercept, x-intercept, stationary points, test for max and min, points of inflection. And then you also do other steps at a tertiary level as well. Okay? And those steps then enable you to literally sketch any curve, which is really cool. Right. I just want to deviate a little bit from the sketching quickly. Right, so if I gave you a function, the same one. Yeah, the same one. And I said to you, for which values of x is the function decreasing? Right, so I know from my theory that I showed you earlier that a function is decreasing when its derivative is less than 0. When its gradient is negative. Gradient is derivative, negative is less than 0. Okay? So what I need to do is I need to find the derivative. So 3x squared minus 2x. I want to know where it's decreasing, so I need to solve where the derivative is less than 0. So where this derivative is less than 0, that's what I need to solve. Right, now this is an inequality with powers bigger than 1. So this is a way that they can test whether you know how to solve inequalities. This is an inequality. Remember, the steps for inequality are everything to one side, 0 on the other, factorize. So you would have needed to take out x, and then you are left with 3x minus 2. Less than 0 means negative. I'm looking for all the x values that will make this expression negative. Remember to plot your critical values on a number line. Okay, so the way to solve an inequality is to use a number line. You mark off your critical values. How do you find your critical values? Put each factor equal to 0. Right? So in other words, put x equal to 0. So x equals 0. Mark it off on the number line. Put the other one equal to 0. So x will equal 2/3, which is to the right of 0. Mark them off on the number line. Less than without an equal means they are open. It means that 0 and 2/3 are not included in an answer. X cannot be 0. It cannot be 2/3. And never lose sight of what you are trying to find. You're trying to find the x's that make this expression negative. In other words, something times something must be a negative. Okay? The easiest way to do it is to use the number line method. So choose something, but not those critical values. So choose something bigger than 2/3, like 1. 3 times 1 is 3. 3 minus 2 is 1. 1 is positive. No matter what number you choose to the right of 2/3, if you substitute it into x, you will get a positive answer. Now choose something between 0 and 2/3. So maybe 1/3. 3 times 1/3 is 1. 1 minus 2 is minus 1. So you get a negative answer. And then choose something less than 0, like minus 1. 3 times minus 1 is minus 3. Minus 2 is minus 5. That part is minus. And then times by minus. Okay? Let's just go through that again. If that is something to the left-hand side of 0, like minus 1, 3 times minus 1 is minus 3. Minus 3 minus 2 is minus 5. But remember, we chose x to be minus 1. And minus times a minus is a positive. And I'm looking to see where this expression is less than 0. In other words, negative. There it's negative. So your answer is there. That answer is x is between 0 and 2/3. Right? There are no equals, so there are no equals. There's no solid. Nothing is included. And it's from smallest to biggest. So x is between 0 and 2/3 if you want it to be decreasing. Okay, so decreasing, derivative less than 0. Learn it. It would be wonderful if you could visualize it. Okay, you visualize it. The graph is decreasing, it's going down. What can you say about the gradients? They are lying this way across, so negative. Negative gradient, gradient less than 0, derivative less than 0. Okay. And then, of course, it hinges on the fact that you know how to solve an inequality. Very, very, very important. This is where they start catching you out. Okay. So they bring the algebra into it. Right. I just want to check in and see if there are any questions yet. I almost thought I saw something coming through just now. Oh, okay. So, Dianne, I've answered that, right? You said, how would you answer if they ask you for which values of, oh, if y is the graph increasing? No, they'd ask you for the values of x such that the graph is increasing. For the x values. Okay? Increasing means that y is increasing. Where is y increasing? For which values of x is it increasing? Okay, then I see you answered. Okay, perfect. All right, super. Right, okay, I'm sure you're ready for another one. The next one that I'm going to do will look a little bit more complicated. Right, x cubed minus x squared minus x plus 1. Okay, I give you that cubic function. And I'm literally just going to say sketch the curve. All right, so we're going to work through all the steps for sketching, first of all, before we look at anything else. Right. Okay, so we know that in the first place we need to find the y-intercept, and that is when x is 0. Right? And if we make x 0, I will end up with y equals 1. So far, I know that the graph goes through y equals 1. I'm then going to find the x-intercept. So I let y equal 0. So 0 equals that, or the other way around. Right, so now I have this cubic equal to 0. Remember, when there's a function equal to 0, I'm needing to factorize, which means you need to go through the steps for factorizing. Step for factorizing is...
I wanted to ask you, if we don't show the steps for factorizing and we just put it in our calculators, is it fine, or do we need to show the steps?
You need to show the steps. Remember that your papers are being marked by examiners that follow memos. Okay. Don't give them any reason to subtract marks. Okay, so in this syllabus, please show the steps. Okay. But remember, you can work backwards. So if you have used your calculator to find these, you can always work backwards to then write it in factorized form. Okay. All right, so if I look at this, there's no common factor. So I can't take out a common factor. That's step number 1. Step number 2 is, how many terms do I have? 1, 2, 3, 4. 4 terms indicates grouping. Now, if I group the first 2 and the last 2 together, I can take out an x squared, and I'm left with x minus 1. I have to take out a sign. I always take out the first of the 2, so a minus, and that's all I can take out, and I'm left with x minus 1. Remember, if you take a minus out of a plus, it changes the sign, because a minus times a minus must get back to a plus. And then I have a common bracket, so I can take out my bracket, and I'm left with x squared minus 1. Right, so that's factorized. This is the difference of squares. Right, so it'll be x minus 1 squared, x plus 1. So therefore, x equals, for this bracket it equals 1, and for that bracket it equals minus 1. So those are my two x-intercepts. If you used your calculator, in other words, you're meaning the silver calculator, you would have ended up on your calculator getting an answer of x equals 1 and x equals minus 1. You will then take it back over. Take it back over. So x minus 1, x plus 1. Okay. And there is a repeated root here. That's why you're getting two brackets. So that would just be a little bit of a clue. All right, so I've marked them off. Now what remains to do is to find my stationary points. Okay. Right, so the stationary points are where the derivative equals 0. I just want to plug in my laptop quickly. I see that it's dying. And the last thing I want to do is disappear. Let's just do that. In case. Okay, cool. Right, so your derivative. Okay, the derivative would be 3x squared minus 2x minus 1 plus 0 equals 0. And then I factorize. Again, you can cheat. You can use your calculator. Okay, you can cheat like the student asked just now, or you can factorize. Because if you cheat and you use that silver calculator, you can then work backwards like I did here. So chuck that over and you get x minus 1. Chuck that over and you get x plus 1. Okay. So 3x, x, 1, 1. And it would have to be a minus there and a plus there. If I multiply this out, I'll get back to that. So either this bracket equals 0, so x equals minus a third, or x equals 1. And then, of course, I need to go and find the partner of each of these. If I substitute 1 in, I'm going to get 0. I'd like somebody to please substitute in the minus a third into this expression and just tell me what you get. I think I remember what you get, so just do it and then I'll know if you're right or wrong. The first person who gets the answer, just shout it out and then I'll fill it in. So you're substituting minus a third in, so use a bracket, minus a third, and then work that out. Are there any takers who can tell me what the answer is?
27.
Yeah, that's right. Okay. And that's 1 and something, right? Okay, so now I have my stationary points. I can quickly plot them. Minus a third and 1 and something would be up here. And 1, 0 is there. All right. And then I'm going to do the test for max and min. So now I'm going to go and find the second derivative. In other words, the derivative of the derivative. So it's 6x minus 2. I then substitute these x's into x. So first the minus a third. And if I work that out, I'm going to get a negative answer. It is irrelevant what the value is. All I'm interested in is to notice if it's negative or positive. Negative means that it is a maximum. So it looks like that. At this point, minus a third, 32 over 27. It looks like that. And 1, 0. If I substitute that 1 in, 6 times 1 minus 2, I'm going to do it here. So second derivative is 6 times 1 minus 2. It gives me a positive answer, which means it is a minimum. It looks like that at that point. And then all I need to do is complete my graph. There it is. Okay, that's what the graph looks like. So you have to go through the steps meticulously. Okay, it has to be done properly. Y-intercept, X-intercepts, stationary points, test your stationary point. And then also, as a habit, find your point of inflection, where the second derivative equals 0. So in other words, where 6x minus 2 equals 0. So x equals a third. So that gives you a point of inflection of a third, and then you substitute it back into the original to find what the y value is. Okay? Don't have to do that now. That's just calculator work. And that means that there is a point of inflection here somewhere. It isn't even noticeable what's happening at that point, okay? But it is a point of inflection. It is where concavity changes. So where it goes from concave up to concave down, or from concave down to concave up. Right. Okay, so this should give you a very, very good base, because if you know how to sketch a curve and you know all the steps that go with sketching a curve, it gives you a lot of understanding for when they give you a curve and they ask you questions on it. All right, which is what I'm going to be doing the next time I see you. So on Monday, I'm going to start working with questions where they're not giving you the formula of or the expression for the cubic function. They are giving you the graph. And then they're asking you maybe to find the equation of the graph or find various unknowns. Okay? And that's where we really see whether you understand and know your theory. Okay? So if I could ask you for Monday, please make sure that you go over the theory. Know that if you want to find a stationary point, it's where the derivative equals 0. Know how to test for a max and min. Second derivative. Is it positive or negative? Know how to find a point of inflection. Know how to find x-intercepts and y-intercepts, okay? The basics. When the basics are in place, everything becomes easier. All right. Okay, let's just have a look and see. I saw a flashing light. So I think there are questions. Aksa, can you just, I don't know how can you maybe call out the question?
Okay, ma'am. The question is minus x cubed plus 3x plus 2 plus 3x, ma'am.
So minus x cubed
plus 3x
plus 3x plus 2.
Yes, ma'am.
Okay, and you wanted to find the stationary point. So it will be when the derivative equals 0. So minus 3x squared plus 3 equals 0. Okay, so minus 3x to the 2, because you're subtracting 1, and then plus the coefficient of x is your derivative. And then you need to solve. So minus 3x squared equals minus 3. Divide by minus 3 and you get 1. And if you square root, you get x equals plus or minus 1. Remember, when you square root or even root, you get a plus or a minus answer. So your one will be 1 something and the other one will be minus 1 something.
Thank you so much, ma'am.
All right, is that where you went wrong? You just had a plus 1.
Yeah,
okay. It's a common mistake. Okay, so just remember, if you even root, you always get 2 answers. It's important. That's why it's sometimes a good idea to rather factorize, hey? Because remember, when you have an equation equal to 0, you're supposed to factorize. So if you take out minus 3, you'll be left with x squared minus 1. And there you have your difference of squares. And there we go. There's the minus 1 and the plus 1. Okay. But either way, it's a good idea to know both. Whether you factorize or whether you did it this way, please don't forget that when you square root, it's plus or minus. Remember your quadratic formula. Minus b plus minus root. It's because the square root is either plus or minus, okay? So whenever you're square rooting, plus or minus. Okay, super. All right, so you guys make sure that you know your theory for next Monday, and we'll do some more examples, but from the other end, the more thinking involved questions rather than just following steps, okay?